Alright, today we're going to be talking about the distance formula and the midpoint formula. We will be able to find the midpoint of a segment in the coordinate plane. We'll be able to find the endpoint given a midpoint and an endpoint of a segment. And we'll be able to apply the distance formula to find the length of a line segment when given the coordinates of the endpoints. So, congruent segments have the same length. Ways we can know they're congruent is by making congruent tick marks. So if EF is congruent to GH, if EF has two tick marks, GH would have two tick marks. Let's say that B is the midpoint here. If that's the midpoint, then it has cut this segment in half, and we would know that AB is the same as BC. So the midpoint of the segment is a point in the middle. So let's say if we go right there, C would be the midpoint, and we would know it's the midpoint because these tick marks match these tick marks. A segment bisector is a line or line segment that cuts the segment in two equal pieces. So it goes like this. We know that AB is the same, A to this line, at point C. We would know that AC is congruent to CB. Now, how do we find the midpoint? To find the midpoint on the coordinate plane, we have our midpoint formula. X sub 1 plus X sub 2 over 2, and Y sub 1 plus Y sub 2 over 2 equals our midpoint. So find the midpoint of the segment with the endpoints 6, 1 and 2, 9. So 6, 1 would be X1, 1 would be Y1, 2 would be X2, 9 would be Y2. So then we plug them in. 6 plus 2 over 2, 1 plus 9 over 2, 6 plus 2 is 8 over 2, 1 plus 9 is 10 over 2, 8 over 2 is 4, 10 over 2 is 5. So that's our midpoint. We could also do it graphically. I'm going to put my axes over here so that I have enough space for everything. So 6, 1 is here, and 2 and we want to find midway. So to go over, we go 1, 2, 3, 4. So halfway would be 1, 2. If we're going up and down, we would go 1, 2, 3, 4, 5, 6, 7, 8. So halfway would be 4. So I'm going to go down 4 from here. 1, 2, 3, 4. And we said over would be 2. 1, 2. That's where we land. 1, 2, 3, 4. 1, 2, 3, 4, 5. Still at 4, 5. The midpoint of JK is at 4, 2. One endpoint is J, which is at 0, 1. Where's the other midpoint K? So what this is telling us is x1 plus x2 over 2 is going to come out to equal 4. And y1 plus y2 over 2 is going to come out to equal 2. We know what x1 and y1 are. So 0 plus x2 over 2 equals 4, and 1 plus y2 over 2 equals 2. And now we can solve both of these. To get rid of the 2 on the bottom, we're going to multiply both sides by 2. Cancel. Zero plus 2, x2 would just be x2, so that equals 8. Again, multiply both sides by 2 to get rid of the 2 in the denominator. 1 plus y2 equals 4, so we subtract 1, we get y2 equals 3, so the other endpoint would be at 8, 3. If we wanted to do it graphically, the middle is at 4, 2, and I'm going to put an M there so we remember that that's the middle. The endpoint is at 0, 1. This is J. So to get from J to M, we go up 1 and over 1, 2, 3, 4. So to get to our other endpoint, we would go up 1 and over 4 again. So that must be K, which is at 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Still at 8, 3. Graphing it is usually easier, but if you get really big numbers that don't fit easily on graph paper, then you're probably going to want to use the formulas. Finally, the distance formula. Our distance equals the square root of x minus h squared plus y minus k squared. xy is one of your coordinates, hk is the other coordinate. So find the length of the segment with these endpoints. So x, y, h, k. Now we're going to plug it in. So the distance equals the square root of x minus h squared plus y minus k squared. 0 minus negative 4 would become plus 4. 4 squared is 16. 2 minus 5 is negative 3. Negative 3 squared is 9. 16 plus 9 is 25. And the square root of 25 is 5. Now there's one other way we could do this. We can do it by graphing. And put it in the middle this time because we have negatives. So 0, 2, and negative 4, 5. So we want to know this distance. But because it's a diagonal, we can't just count the boxes. But what we could do is turn it into a triangle. This side of the triangle has a length of 1, 2, 3. This side of the triangle has a length of 1, 2. Oops, I marked that in the wrong spot. I miscounted. 0, 2, negative 4. 1, 2, 3, 4. 1, 2, 3, 4. 5. There we go. Sorry. So this side of the triangle still has a length of 3. This side of the triangle has a length of 4. And we want to know this side. If you remember, the Pythagorean theorem is c squared equals a squared plus b squared. 3 and 4 are a and our b. And we're trying to find c squared. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. To undo the square, we square root. So we get that that third side is 5, just like with the distance formula. Go ahead and fill out your summary.